This is I do, you do over scale and scale drawings and scale factor. So you notice here that I have a picture of the United States and it's pretty small, and right now if you can see it, this distance right here, you can barely see it down there, is I believe 500 miles. Okay, and we'll increase it a little bit. I want to show you that increase. That increase or scale change then is when you grab it and grow it proportionally. So now you can see what used to be 500, I guess it's kilometers rather than miles, but 500 kilometers used to be this long. Now 500 kilometers is this long. I'll change it one more time then. Now I've grown it proportionally to where 500, oh, that other thing grew with it, but now you can see how much longer this 500 kilometer thing is than the original size that I had it in. Those were examples of a scale change. And up here at the top you can see the scale is a ratio of change to actual measurements. So this is not the actual size of the United States. This is the changed measurement, right? Okay, so we've shrunk it down so it can fit on this screen. That's a scale change if we keep it proportional. As long as we have this thing growing and shrinking in a proportional manner, and I'm not changing the ratio of length to width, then I'm keeping it proportional. That's also called similar. If I grow it or shrink it in a proportional way, this symbol means similar, which means grown or shrunk proportionally, also considered or called a dilation. Here you see two triangles with a similar sign in between. That similar sign is saying that a scale has been used, that it's been grown or shrunk proportionally. You can see the actual one is the larger one, so this has been shrunk proportionally. If I want to tell you how it's been shrunk or to write down the scale, I just write it in the order of changed over actual and then simplify it. So I have corresponding side of 15 on the actual that is changed into a 10. So if I simplify that, the scale is 2 to 3. This thing is 2/3 as long as it used to be. So let's say we knew that this other side over here was 12. One thing you could do is to change it. You could just take it times that 2/3. That scale, that's a scale factor since we have the same labels because there are no labels. So you could just take it times 2/3, which would get you 8. That means that side would be 8. Another way to set it up is with a proportion. Writing changed over actual, and then keeping your order straight. So maybe I know that this other side is 21. And so I could say, well, I know that 10 has the same relationship to 15 as this unknown x does to 21. X is to 21. So 10 is to 15 as x is to 21. You'd then, of course, be ready to multiply your diagonals and divide, because really, once again, this thing is a proportion. Scale is a proportion, and that would get you your answer of 14. So now I would know the changed measurements as well as the actual measurements, and we can do that with a proportion or with the scale factor. If we have that as well, we can simply multiply the actual to get there. If you had the changed measurements, you would need to divide by the changed measurements. So maybe I didn't know this was 21, but I knew this was 14. Then I could, instead of using the scale factor to change it, I need to undo it by dividing by the scale factor. So I would divide 14 by 2/3, and that would get me that 21. So this problem tells you that on a map, 1 inch equals 40 miles. Right there, they gave you the scale. 1 inch equals 40 miles. So we could be setting up a proportion here, and I'll do that, but I'm also going to show you how to change that into a scale factor, because right now it's simply a scale because we're going between two different labels of inches and miles. Now, if I want to go ahead and solve this problem, it says, how much would 2.7 inches represent? Well, that goes on the inches side, so now I'm ready to multiply and divide, and I get my answer of 108 miles. Then it says there's another part of this problem, and I'm going to go ahead and set up the exact same thing. 1 over 40, that's inches over miles. And then it wants to know how many inches 416 miles would be. So you're ready to set that up and multiply and divide. And your answer would be 10.4 inches. And what you might notice is this thing is set up. Once we have the scale, it's set up to change any amount of things on this map, either change from change to actual or change back from the actual back to the changed. If I wanted to write this 1 inch over 40 miles as a scale factor meaning it has the same labels, then I would either need to go to both inches or both miles. I'm going to go to both inches. And how would I do that? Well, 1 inch is already an inch. If I want to go from miles to inches, there are 5,280 feet in a mile, and then there are 12 inches in each one of those feet, so I would need to multiply by 5,280 and then multiply by 12, which is 2,534,400. And then once the labels match, you can erase them, and you can change anything on there by taking it times 1 over 2,534,400, which isn't really useful in this case, but there are times it's useful to have it if you're going from feet to inches or something like that, or inches to feet. It's kind of handy to have a scale factor rather than using 2 labels. I had to edit this last question because of some poor grammar. So the last one says, the movie studio would like to turn this poster for their new movie, The Fraction Menace, into a billboard that is 10 feet tall. What is the scale factor? Well, to set up a scale factor, I just need the changed over the actual, but it does say scale factor, so I don't want to have different labels. So let's see. We want the change to be 10 feet, and the actual is 15 inches. Well, now that's a scale, but it's not a scale factor because they have 2 different labels. So aren't there 12 inches in each foot? So I'm going to just take that times 12. That would be 120 inches over 15 inches, which then, of course, the inches can disappear, and that fraction will simplify to 8 over 1. So really what we need to do is we need to make this thing 8 times bigger. That will grow it proportionally. Does that make sense? Now that I know that, I can do that 2 different ways. Changed over actual, and I go back to this and say, oh, if I want what the width is going to be on the billboard, I take this actual distance of 9, and it's in inches, right? And take 9 times 8 and get 72 divided by 1. Of course, that's multiply, divide. And since I put in inches, I get out inches, so our answer is 72 inches, which we could, of course, simplify if we wanted to 6 feet. So this poster is going to be 10 foot when I grow it proportionally. Let's see if I can grow it proportionally. Oop. It's going to be 10 foot by 6 foot grown proportionally.